Okay, so let's start. We have very short time. I will tell you about native browser promises in JavaScript. This is an API that was introduced quite recently, but it's quite an interesting one, very nice concept, in my opinion, and I would like to tell you a little bit about it. So starting off, a few things about me. We only have half an hour, so no way I can tell you much about me. I'm working at STX long. I am doing Python and JavaScript. That's all you need to know for now. If you want to refer to those slides later on, those are the links. I will also display them at the very end of the presentation. So let's jump right into it. What are promises? Well, promises, in my opinion, are the long-awaited saviors that will free us from the chains of callbacks. What do I mean by that? Well, this is very standard code using jQuery to make an Ajax request and respond to it. So you are making an Ajax call, you are passing in some parameters, and then you are passing also the success and error callbacks. And those callbacks will be executed whenever the request either succeeds or fails. What, in my opinion, is wrong with this approach, even though it's so widespread? The problem is that you are mixing the parameters of your request and what should happen after it's done. You have here in this object those options that you are passing to your Ajax call. You have both the parameters and also some actions that should happen when this finishes. But why does jQuery Ajax need to know what I am going to do with this response? It doesn't make sense, does it? It shouldn't know this because it's not part of what it should do. jQuery is making the request either succeeds or fails, but why is it executing my callbacks? Why is it its responsibility? It really shouldn't. How it should look like? Well, I would very much like it to work like this. I have some function, I'm passing only the parameters, and this function returns me something. Let's call it a promise of getting a result. And then I can connect to that promise those callbacks. So I'm saying that when this promise succeeds, then I want to do something. If this promise fails, I want to do something else. And then I am able to have a decoupling between the parameters and the actions that I actually want to execute whenever the action finishes. And this is actually possible to implement. It's quite simple. You need to use this new API of promises. It's a very simple API. There's basically like one set or class that's called promise. You return a new promise that executes all the same code, except that it doesn't execute the callbacks. The callbacks, they don't come into here. They just don't. They are not part of the parameters. What happens is that this promise, it always gets two callbacks that are used for resolving or rejecting a promise. So this callback should be executed when the promise succeeds, and this one if the promise fails. So I have all the stuff that I had, but here in the success, I don't pass the callback from the external callback. I just resolve my promise, or I reject my promise. And this way, the code for example, printing the data to the console is not part of this. No, this only deals with the Ajax call and how to get the result. So how, when it fails or when it succeeds. But it doesn't have anything to do with handling the data. Also, please notice that I'm just resolving my promise or reject my promise. The problem with callbacks, the other problem that you have if you are using callbacks in the standard jQuery model, is that if you want to handle this stuff, so when jQuery is executing the success callback, this callback can fail, right? It's not guaranteed that you'll pass it the right code. So then jQuery needs to take care of handling the errors in your code. It needs to have a try-catch and so on and so on. This is beside the point. In this promise model, the promise is taking care of everything, of handling what's happening, and it doesn't execute the callbacks. No, it just resolves itself and makes the status being known. I am either resolved successfully or not. But callbacks, they are being added later. They are added outside the promise itself. So once again, getting back, what are promises? Promises are objects that are used for asynchronous processing. They are used whenever an operation happens that doesn't have to return you a value straight away. So for example, if you are making an AJAX request to the server, you are making a request, the response doesn't come straight away. It takes some time to come. Also, it might fail. It might fail not straight away. It might also fail in like 2 seconds. The server thinks, and then boom, it raises an error. In other words, promises are proxies for values that are not known when you create this promise. They are basically proxy objects. How do they look? Well, you've seen in the previous example, the API is pretty small and not complicated. You create a new promise and you pass it something that they call an executor. And this needs to be a function that accepts 2 arguments. One is the resolve callback and one is the reject callback. And those callbacks you will use to either resolve or reject your promise. Pretty simple. The promises can have 3 states only. They can have a pending state, fulfilled state, and rejected state. Of course, fulfilled state is when the promise is resolved. Rejected is when the promise is rejected. And pending is before any of that happens. So looking at this code, what will be the status of the promise once you execute this code? Well, you create a new promise. Once you create it, the first line inside it, within the executor function, the promise is pending because you did not resolve or reject it yet. So the promise is pending, and it is pending until you call either the resolve callback or the reject callback. And once you call one of those, the status of the promise changes to either fulfilled or rejected. Very, very simple mechanism. And then you can connect stuff that is supposed to happen when the promise is either resolved or rejected. Very simple API. There are basically just 2 functions. There's a function called then and there's a function called catch. This one attaches itself to the fulfillment of the promise and this to the rejection of the promise. Those functions, they always get 1 argument only, and it is the result of the promise. So whatever you pass to the resolve callback. If you do resolve and you pass in the number 7, this is what you'll get here. And if the promise is rejected, also the argument to reject comes here. And there always can be only 1 argument. The interesting fact is that with this API, you are able to connect few actions to the same promise. So you are making an AJAX call and you want few things to happen. For example, you want something to be logged and you want some HTML to be updated. So you can connect 2 different handlers to it and it will just work. You just call promise then a few times, passing in few callbacks. Very easy. And that basically is all you need to know about promises. Isn't it beautiful and simple? Yes, it is. I was just joking. We are pushing on. But you must agree that this was promises basics. There's nothing else. There's nothing else there. There's not much else to add. This is the whole concept. It's very simple, very elegant, and in my opinion, very nice to use. And I think it can simplify your code quite a bit. But you are probably thinking, where can I use those? Well, the good news is you can use it almost everywhere. From what I read, even the Android browser added support recently. The Microsoft Edge supports it. Internet Explorer, of course, it doesn't. One thing that is not on the slides is Node.js. Node.js, of course, supports it. So the support is pretty widespread. But if you think that you cannot use it because you need to do something for Internet Explorer, are there alternatives? Of course there are. Well, few libraries are tackling this on their own. There's API in jQuery, jQuery DEFERRED and jQuery Promises. It's basically it's the same concept basically, just implemented by jQuery. So actually, this example that I was showing with jQuery, it could have been done with the jQuery promise implementation, but you can also use the native ones. The syntax and everything else is very similar, as you can see. AngularJS, of course, as some of you know, I'm not a big fan. Why am I not a big fan of Angular? Because it also tries to imitate a few things that are already there. And this imitation of promises is like so thin. The only thing that is different in this example than the one that I was showing using native promises is that here you have $Q instead of new promise. So that's a very minor thing. No point in using Angular $Q, is there? And also there are some other libraries that are basically implemented promises in JavaScript. There's a Q library, there's RSVP, and there's also when. So you can use those. OK, so we know that we can use those pretty much in most of the places. Let's talk about the utilities. There are a few things apart from the constructor. There are some utility functions. Using resolve, you can create a promise that is straight away resolved. If you don't have to write new promise and in the executor write resolve from this value, you can just use this function to create an already resolved promise. And similarly, there's a function that creates an already rejected promise. A very nice thing is combining promises. There's a function called all that you give it an array of promises, and this creates a new promise that will only be resolved once all of the promises you pass in here are resolved. So it will wait for all of those. So if you have a situation in your code where you are doing 2 AJAX requests, and then you need to process both results at the same time, you need to wait for both of them to finish before you start your processing. So you just use promise all, pass in those 2 promises for AJAX, and the callback will be executed only once both of them are resolved. In case either one of those or all of them fail, this error handler will be executed. It will be executed only once. If both of the promises fail, this callback will be executed only once. So it's pretty nice, and it's pretty much what you would expect. Then, if you had a need to wait for only one of those promises to finish before processing, you can use the race method that will choose the fastest, the promise that will be resolved the fastest. So only one of them needs to be resolved before the code executes. So once you execute this, you can see that all of the promises are finishing at some point or another, but the callback, so this one, is being executed once the first one finishes. And the other ones, this one doesn't care about them at all. Another very nice thing is chaining. Let's say we have a function that returns us a promise that will be resolved sometime in the future. This one returns a list of cities. Then we want to have this code that first gets a list of cities from a server, let's say. This is emulating the server in a very crude way. Then you want to map them to uppercase, and then you want to also pad them to be as long as the longest element and insert, for example, asterisks. So you can use promises and chain them. So you create a promise. That's your promise. Then you chain it into the uppercase method, and then you chain the result of uppercase to the pad method. And you get the resulting promise that when is resolved, the result first comes from this promise. It waits until this is resolved. It's passed on to this callback. The result of this callback is passed as an input to this one. And you get the results as you thought you would. So you would get the list of the cities, uppercase, and padded. So very nicely, you can chain the results. But this is nothing, because this you can just do with plain functions. You could just put this uppercase and pad here. You could just do result equals uppercase from result, and then result equals pad from result, right? You could do that. So that's nothing new. But it goes deeper because you can also nest them. what does it mean? It means that those functions that you pass in as handlers, they can also return promises. We have a function here that returns a city, and then it returns a random city from this list. This is basically a random choice from the list. And then we have another function that gets a city, and also with a promise, it resolves to the manager of that STX Next office, for example. And please notice that this fetch manager, it returns a promise, so it's not resolved immediately. It returns a promise. And then you can nest this. So you are first creating the city promise, then you're passing it to the manager thing. The fetch manager, it will return a promise, and this callback will not be executed until the promise returned by fetch manager is resolved. So it resolves the nested promises. Pretty cool. And now I have a riddle for you. So this is a simple one. There will be a harder one. This is a code using set timeout. What is the resulting order of the things that will be printed to the console? Who thinks it's option number 1? Please raise your hand. Who thinks it's option number 2? Cool. I'm very happy that nobody said option 1. Of course, it works like this. You start executing this code, it executes this statement, then this statement is deferred, so we are pushing it to the task queue. This executes, then we are ending this function, and then we are trying to process the tasks that we have referred. So we will process this task, and this will be printed out. So prepare yourself for something harder. So we have some code, some synchronous code, then we are putting something to set timeout, then we are creating a new promise that is also logging something inside the executor. We will resolve this promise pretty fast, and then there's some handler to the promise being resolved. So how will this be printed out? Anybody cares to take a guess? Zeph, please. Okay, that was very wrong. I mean, I thought you will do it wrong, but I thought you will do it a little bit better. Come on. You should have guessed that this promise constructor, this one is executed synchronously. Of course it is. Shame on you, man. But that's not the interesting bit. So the executor is executed right when you are creating the promise. So this is executed straight away. The interesting part is that you have the callback to the promise being resolved, and we would probably expect it to be deferred. It is deferred. Now, the interesting bit is that what will be printed out first, the timeout or the promise resolved callback? Turns out that even though the timeout was scheduled first, the promise handler was executed first. First the promise handler, and then the timeout. That's quite strange, I would say.
Isn't that type of implementation specific?
No, it's defined. I will tell a little bit more about it in a second. So, why did it happen, right? So even Zeph was surprised. So the answer is microtasks. There's something called microtasks. And this is how promise handlers are being handled, by microtasks. The question now is, what are microtasks? No, the right question is, what are tasks? First, we need to ask ourselves this question. So, what are tasks? Whenever you have something big happening in your JavaScript, for example, you click on an element and there's supposed to be a click handler firing. That's a task. Whenever you put something with set timeout to be processed later, that is a task. What are microtasks? Well, so far, from what I read, there are not many examples of microtasks. Something that is involved with mutation observer API is using microtasks, but mostly promises are using microtasks. So How are those microtasks handled? Well, I have an interesting fact for you. Did you know that event loop has more than one task queues? So far, I was thinking that there's only one task queue. When you're doing set timeouts, stuff is being added to the queue. When you are clicking on an element, also the callback is added to the task queue, and it's being executed by the browser. Well, turns out there are few of those queues. This is basically the event loop processing, and I was reading into the specification. So this is not implementation dependent. This is by specification. The thing is, Firefox did it right at some point. Then they had a regression where it doesn't work as you would expect. But Chrome and all the other stuff and Node.js, they are all working the same way. So this is basically a shortened version of the event loop. How does it work? Well, there is a task queue, and at the beginning, you just pick up a new task, the one that is scheduled to be executed first. You are running this task, so executing the code associated or the callback associated with the task. Once this is done, you thought that you are giving back the control to the browser and you will render, and then you pick up a new task, right? Well, it doesn't happen like that, not anymore, because there's an additional step called handling microtasks. I was not aware of this. I was quite shocked to find this out. How does it work? Well, it picks up the oldest microtask from the microtask queue. There's a special queue where microtasks are being put. Then you are running this microtask, and then you are repeating this step until there are no more microtasks. So you would go back to here, pick up a new microtask until all the microtasks are done. What does that mean? It means that the rendering is being deferred until you clear the microtask queue. Only once there are no more microtasks, the browser can render, and you can go back to the first point, so picking up a new task. So, are promises asynchronous? Well, as we showed in the example, yes, they are, but not in the way you would expect them to work. So, I have this question: is promise then the new set timeout? You can use promises to defer execution of a callback, right? We just showed that. You can also use set timeout to defer an execution of the callback. So these are two methods that are supposed to be doing the same. The difference is this puts the callback into the task queue, and this one is putting the callback into the microtask queue. So is there a difference in the way they work? Well, I created a little experiment. There's a function here. Let's say that this is like asynchronous computations, fake ones. We are adding lots of numbers to themselves. It works like this. There's a long computation. Let's say I don't know, 100 milliseconds. Then we are deferring the execution of the next step. Then in the next step we are doing again 100 milliseconds of computations, and we deferred. So we would expect it to work like this. 100 milliseconds processing, then control goes back to the browser, we can refresh. 100 milliseconds we are processing, we give the control back to the browser can refresh. And I have an experiment showing how this will work if we are using either the set timeouts or we are using promises. So this is an animation done purely in CSS. That's why it's so nice and smooth. If I click on one of those, it will start executing those computations. So I click on the one that is using set timeouts. You can see that the browser is no longer doing it nicely. You can see that it's 100 milliseconds it's processing, only then it is able to refresh. Then it goes back to processing, and so on and so on. So this was the version with set timeouts. This is how the tasks are being executed. And this is the one that is using promises. I clicked, and what happened? My browser froze. Why? Because when I'm deferring the execution of the next task, it's adding it to the microtask queue. So I was handling a task that was already in the microtask queue, and then at the end I created a new microtask. So In the slide previously, you've seen that the step is actually to execute all the microtasks until there are no more microtasks. So if you have a microtask that creates another microtask at the end, you'll have like an infinite amount of microtasks being created, and the control will never get back to the browser. The browser will not refresh. It will keep processing, because that's how the event loop is structured. The thing is that the microtasks, you can see they are much faster. The amount of computation is the same, and they were done in 10 seconds, and the tasks are being done in 12 seconds. So they are faster, but they are not letting your browser do its work. They are basically hanging your browser. So I was pretty surprised with this result. So that would be it, what I wanted to show you about microtasks. My main point is promises are good. Please use them. They are better than writing callbacks. Here are some sources that I was using. You can look it up. Thank you, and are there any questions?
My question is, do you know whether the now called polyfills like $Q or RSVP or when also use the microtasks?
Well, as far as I didn't check this. If I would expect them to check whether the promise API is present. If it is, I would expect them to use the promises, the native promises. If not, if you are, for example, using Internet Explorer, they are probably falling back to set timeouts.
And more general question, do you know whether the microtask API is public, or is it, can it be used only by the browser's internals?
As far as I know, there's no way for you to create a microtask just like that. I think you can use it as a side effect of using promises. I am not aware of you being able to create it just like that.
Understand. Thank you.
One quick question. You mentioned that there are few tasks in the browser, queues, right? So the tasks, micro tasks, and is there any other?
Well, I didn't look that much into it. I just know that there are those two. I always thought that there's only one queue, that everything is being taken from the same pool. Seems like it's not. There are at least two.
Some of current implementations of promises have also notify and progress callback. Do you know whether the native implementation has them as well?
As far as I know, this is all the API you have. So you have just the then, catch, and then all those stuff for combining. There was no thing for notifying.
Okay, thanks.
The API is really, really simple. If you look it up on Mozilla Developers Network, the page is very short and brief, and that's why I think this API is so beautiful, because it's just so simple.
Actually, I think I saw the discussion about the progress callbacks, and then basically they decided that it was a bad idea. Like it should be like an event system, not a part of the promises. Okay, my question is like, so I was also shocked, I must say, about the microtasks. Can you defend this choice? Can you explain like why they did it this way, or is it more like a freak of nature kind of thing?
I think they did it for performance reasons. This promise callbacks are one of the things that this is used for. The other one was the mutation observer that I was mentioning at some point. Yeah, mutation observers. This is some API that allows you to listen on to DOM modifications. So this has a potential of being executed many, many times if you are doing some big changes in your DOM. So I think that's why they did it, because this, the thing is that creating a task is a significant amount of resources wasted. As you've seen, this stuff that I was showing, this experiment, it was executing the calculations only 100 times. So there were only 100 interruptions in between. And the difference was already big. It was 2 seconds of difference in 100 iterations. So the difference was quite significant. So the way they are defending is that creating tasks is just costly, and the microtasks, they are just more lightweight.
I have one simple question. Because you told that in callbacks, callback is executed by jQuery,
and in promises not. So the question is, how is this binding resolved? What is this in the context of function defined in then?
Well, there is no this unless you bind your promise into unless you bind the function to some context. There is no context. If you happen to have an error in your callback, the browser will show you that there was an error thrown in the callback. You can expand the call stack, and it's really, really short. Like there's nothing executing this. You'll only see very like 1 line, 2 lines tops, because there's like nothing wrapping this around.
Okay, if that's it, thank you very much for your attention.
Thank you.